Hello and welcome back. In this video, we resolve a force vector along an arbitrary direction. Now consider a force vector F. We need to resolve this vector along a line AB which is inclined at an angle theta to the force vector. Let U be the unit vector along the direction of the line AB and let FAB be the projection of force vector F onto the line AB. Taking dot product of the force vector F and unit vector U, we get FAB, which is the projection. Note that the magnitude of the unit vector is unity and the magnitude of force vector times cos theta is FAB, which is the projected length. Now we can write FAB as a vector by multiplying the magnitude FAB with the unit vector U. This vector is the component of force vector F along the direction AB. Subtraction of this force vector FAB from F, we get the vector FCD, which is the component perpendicular to the direction of AB, which is along line CD. Now, consider an example. A force of 300 Newton is acting on a structure at a point B along the direction A. Resolve this vector along the structural member AB and perpendicular to it. The first step is to find the unit vector along the direction AB. Since the coordinate system is located at A, we can find the position vectors of point A and B. From this, we can find the displacement vector RAB. Using the magnitude of vector RAB, we can find the unit vector. This vector divided by its magnitude will give the unit vector U. Now we have the unit vector U and the force vector F. Taking dot product, we get the magnitude of the component along the direction AB. Multiplying this with the unit vector U, we get the force component along the direction AB. And subtracting this vector FAB from vector F, we get the force vector FCD, which is the component perpendicular to line AB. Another example, force is applied at the point A of a pole as indicated. Find the magnitude of the projected component of this force along the pole. Since the positions of point A and O are given, we can find unit vector along the direction OA using the method we discussed previously by finding position vectors of RO, RA. We can find the displacement and you can find the magnitude. From that, the vector divided by the magnitude, you get the unit vector. Since we have the unit vector, we can take dot product of the unit vector with the force vector F, and you get the component magnitude of the component along the direction OA. And from that, you again multiply that component, the magnitude of the component times the unit vector, you get the force vector component along the direction OA. As we discussed earlier, when you subtract the component along the direction OA from the force vector, you get the component along the direction AB. And finally, we can also show that the magnitude of the component is essentially 31.9 Newton in this problem.